Before talking about the arrow of time, we need to introduce the notion of time. Here is a quote of Aristotle. Since the past is no more, since the future is yet, and the present is already gone as soon as it began, how can there be time? We can't precisely define what is time without presupposing the idea of time. As an example, if someone asks you to define time, you know what it is, but you won't be able to explain it. This is called a tautological definition.
However, we can distinguish two different types of time: physical and psychological time. Physical time is a dimension of the succession of instants. You will see it on a clock with the hands which are showing a succession of fixed instants. Psychological time is the perception of time which anybody has according to the activity of people. When you get bored and begin to count each second, psychological time joins physical time. Those two definitions are different in a certain point of view. In the physical time, present, which has a null duration, is the border between past and future. Whereas in the psychological time, we still have some seconds from the past into the present. For example, when you have a song in your head, you always have the precedent musical notes. After all, we noticed that time goes always from the past to the future, and this independently of time.
When a drop falls on the ground, it seems to be logical that it can't reform anymore. It's an irreversible phenomenon. It's the same for a glass. When it shatters on the ground, it can't instantly reform. If you have understood this, you have understood the essential of the arrow of time notion. It's the causality principle. Every effect is preceded by causes, and it can't affect its own cause. Causality is always true in science. Therefore, time can only be linear and can't be cyclic. Time is not often depicted as a straight line with an arrow. Time doesn't have to be a straight line, and it doesn't have to be regular. But it always flows in the same direction, from the past to the future.
We take a glass of water. We put an ice in it. We all know what's going to happen. The ice cube will melt. But what does that mean? It means that the ice cube will go from an organized state to a disorganized state to form water. What are the odds for these molecules to rearrange themselves in order to form ice crystals again, spontaneously? It's just impossible. What statistics tell us is that these water molecules can only get more disorganized. Well, in science, we have a means to measure that, and it's called entropy. Entropy is what allows us to measure the amount of chaos in a system of thermodynamic particles.
On the microscopic scale, every phenomenon is reversible. By reversible, we understand the fact that it can happen one way or the opposite way, and not that it goes back in time. There's no phenomenon at the microscopic scale which can only happen one way. On the macroscopic scale, like for example the glass shattered on the floor, some phenomena are irreversible, which means that time has an arrow. At the macroscopic scale can emerge something different which doesn't exist at the microscopic scale. And that's exactly the question that asks the arrow of time. How can it be that at some point, seemingly out of nowhere, an irreversibility occurs? If we take a deck of cards perfectly organized and we shuffle it, it's impossible for the deck to be in order unless you are cheating. That explains the irreversibility of time.
We can finally say that the arrow of time is the irreversibility of certain physical phenomena.